Okay. So, hi students, welcome to Shankar Medico Academy. Today we are going to see the relation between the hydrogen spectral lines and then Bohr's radius related problems. Generally, in hydrogen spectrum, if you see, there are several series of lines you are expecting in hydrogen spectra, namely Lyman series, then Balmer series, Paschen series, bracket series, and then Fund series. So, how do you understand these things and from where these series have been generated? So, let us see a little glimpse of the origin of this series or line spectrum in hydrogen atom. So, generally what happens if you are having different energy levels, imagine different energy levels. So, imagine we have the electron in the ground state. Whenever you are supplying the energy, so let us take you have supplied the energy. So, the electron will be promoted to higher energy levels. So, and electron is not stable in the higher energy level. Again they will return back to your ground state. So, during that, whenever electron drops from the higher energy level to lower energy level, they emit energy in the form of light, So, these correspond to the different series of lines you will be expecting in hydrogen spectrum. Okay? Then you may be asked the question, hydrogen has only one electron, then why we are having the different lines in hydrogen spectrum? So, this is nothing but we are not dealing with only one hydrogen atom, we are dealing with so many hydrogen atoms. When these hydrogen atoms subjected to the electric discharge, then what happens? Different hydrogen atoms will absorb different amount of energies. It means they have the different wavelengths. So, by taking this energy, the electrons of the different hydrogen atoms will excite into different energy levels. So, when they will drop from the higher energy level to lower energy level, we will be obtaining the different types of lines in hydrogen spectrum. Then, if imagine, let us take n is equal to 1, I am writing the energy levels. So, n is equal to 2, n is equal to 3 and so on. So, imagine if all the lines falling from the higher energy level to only n value equal to 1. It might be infinite, n is equal to infinite, from there also lines are falling only. So, if the electrons is dropping from the higher energy level to lower energy level. So, whenever it is dropping, then we are getting energy in the form of light. So, if whenever electron is dropping from, even though in n is equal to infinite, if it is dropping to n is equal to 1, so these lines we are calling as Lyman series. So, Lyman series means what? Electron can come from any energy level which those energy levels higher than n is equal to 1. It means what? My n value is equal to 1. If electrons are coming from, let us take n value is equal to 2, 3, 4, 5 and so on. If electron is coming from n is equal to 2 to 1, n is equal to 3 to 1, n is equal to 4 to 1, 5 to 1. So, everything is falling on n equal to 1. So, these lines we are calling as Lyman series. What is that one? Lyman series. Imagine if I am having n is equal to 2, that means whatever the higher energy level, let us take n is equal to 3, 4, 5, 6, these are the higher energy levels. If electrons are, okay, so if electrons are dropping from, let us say 3 to 2 or 4 to 2 or 5 to 2. So, if all the electrons, are dropped from the higher energy level to, let us take n value is equal to 2, then this series corresponding to your Balmer series. This is Lyman series, this is the Balmer series. Similarly, if I am having n is equal to 3, let us take, what is n is equal to 3? Higher than this energy level, let us take 4, 5, 6. If electrons are dropping from higher energy level to n is equal to 3, this series corresponding to we are calling as Paschen series. Then similarly, if electrons falling from the higher energy level to n is equal to 4, we are calling as bracket. Then similarly, if electrons are coming from the higher energy level 2, if they are dropping to n is equal to 5, then the corresponding series we are calling as Fund series. So, Lyman, Balmer, Paschen, bracket and Fund series we are obtaining in hydrogen spectrum. Okay. So, now how it is related to the Bohr's radius? So, let us go with this. So, what is the Bohr's radius? So, Bohr's radius is nothing but it is the radius of the first orbit. So, generally radius of the first orbit we are writing as, let us take A naught. If you want to represent in terms of picometer, we can write as 52.9 picometer. Same A naught I am calling as Bohr's radius here. So, you can also write as 0.529 in terms of angstrom. Same A naught you can also write as 0.0529 in terms of nanometers. Now, if I want to measure my Bohr's radius, how it is related? So, Bohr's radius is related to your A naught then n square. So, according to the units, okay, we need to choose your A naught values. For example, if I want R value in picometer, my A naught value I have to choose only 52.9 picometer. Okay. If I want R value in terms of angstrom, I can use this one 0.529 angstrom. If I want my R value in terms of nanometer, then I will be using 0.0529. So, this is our relation. So, the radius of any orbit you can predict by using this relation. Okay. So, A naught based on the unit you can change. For example, if I want R value in picometer, so this equation I will be modifying as 52.9 multiplied by n square. So, that means if I am having R value in terms of picometer, then I will just divide by this one, so that I can get your n value. So, let us apply this formula to the problem. So, this is the problem given. Okay. Let us try to understand this problem. So, the electron in the hydrogen atom undergoes transition from higher energy levels to the orbit of radius. So, they have given your radius of the orbit, it is 211.6 picometer. Since R already in picometer, I will be using Bohr's radius A naught in terms of 52.9 picometer. Okay. So, then what they are asking, this transition associated with, that means what, this transition is corresponding to what kind of series? As I already mentioned, if you know the n value, if n is equal to 1, it is Lyman series, n is equal to 2, it is going to be Balmer series, n is equal to 3 Paschen, so and so on, we will be calculating or evaluating the type of series of spectrum present in hydrogen atom. So, our aim is to find out n value. If you know the n value, you can easily predict what kind of series it is. So, to do that, what we are using, R value in terms of picometer if I take, then I can use as 52.9, this is in picometer into n square. So, radius they already given, radius of the orbit they already given, how much it is? 211.6 picometer. Then my Bohr's radius in terms of picometer I am writing as 52.9 picometer, and from here I can get your n value. So, picometer I can cancel, this will go into 4 times. So, what I am going to get here? My n square equal to 4, n value how much? 2. So, n value corresponding to 2 is nothing but what? Your n value is 1 means Lyman, n value is 2 means Balmer series. So, your option is D. So, what we have done? We have interrelated the concept of the spectral lines, hydrogen spectral lines, with Bohr's atomic radius. So, we can also predict what kind of line spectrum will be generated if you know the radius of the orbit. So, this is what the interrelation formula, and I hope you enjoyed this discussion. So, thank you so much.